All right, great. Welcome to another Webinar Wednesday sponsored by IPDE, the Institute for Professional Development of Adult Educators, and the Florida Department of Education. Thanks for being here. Today's topic is balancing chemical equations made easy. So, yeah, let's get right to it. My name's Harold Gertner, and I'm an IPDE trainer. And here you can find my email if you have some follow-up questions for related to this or some of the other webinars I've done recently for IPDE. It's just hgertner@floridaipde.org. And yeah, please feel free to reach out. I've been training for IPDE for a little while now, and I'm excited to be back again for another Webinar Wednesday. And yeah, thanks for the Florida DOE and IPDE for having me. Now, a few things, just kind of housekeeping and things to remember. Um, we're in a Zoom meeting today, and it's listen only mode. You're muted, but please participate. Feel free to participate in the Q&A or the chat uh, option. And in fact, I'll encourage some participation at a few points, even if you don't have any specific questions. I hope you'll share some answers to some questions with me. And we are being recorded today, and that's mainly so that you can review this later. And so this is going to be archived at IPDE within just a few days, and along with a handbook to accompany this webinar. And if we have time later in the webinar, I'll remind you where you can find those things under the IPDE webpage when you're logged into your account there. But for now, that's just a little quick housekeeping. Get your chat bar ready and your Q&A option ready. And yeah, let's get going. Talk a little bit about chemistry and chemical equations. So really, that's what we're going to get into today. A little agenda here. We're going to talk briefly about the chemistry that's on the GED and where that fits in with the science portion of the GED. We'll talk a little bit about what high impact indicators are and specifically some indicators related to chemistry. And then we'll jump a little bit into the subject of the day. We're going to look at the specific topic of chemical equations, but also hopefully this will encourage you to use other sometimes overlooked subjects in the science curriculum as vessels for exciting lessons as well. So a little bit of a kind of a broad and narrow focus at the same time today, I guess. But we're going to jump into a little bit of what chemical equations are, the concept of conservation of matter, identify and review some of the parts of a chemical equation, and then all of that will lead us to the different types of questions our students can answer with just varying levels of study. So there are some questions on the GED that students can answer about chemical equations that don't require balancing and but require understanding a little bit about what's going on. And then there are some related to actually how to balance. So we'll talk about some different balancing techniques and work that process together. And then we'll close with some kind of ways to make chemical equations and chemistry even more fun in your classroom without much effort. And if we have time, look at a few actual lesson plans, but those will also, that's what will be in your handbook to accompany this as well, this webinar today as well. So that's a little bit of where we're going. So thanks again for being here, and let's just dive right in. So chemistry, why chemical equations? Well, they're on the GED is the simple answer, and that's what we're here talking about preparing students for. They're covered in the physical sciences portion of the GED. The GED science section is broken down like I have on the board here, approximately 40% to life sciences, 40% to the physical sciences, and 20% to earth and space science. Chemistry is under physical science, and specifically under there, if you look up under the curriculum frameworks, you'll find balancing chemical equations and different types of chemical equations, conservation of mass in balanced chemical equations, and limiting reactants. And so that's the real specific curriculum framework point. Um, which of these sections, life science, physical science, or earth and space science, do you think most uh, GED adult educators are the most comfortable reviewing or teaching with their students? Anybody in the chat want to share? Life, physical, or earth and space science? What do you think gets covered the most often? Exactly. Yeah, I agree. Oh, a lot of life. Oh, all right. Fair enough. A lot of life science. I was going with Jesse's original answer there. I feel like a lot of people gravitate towards Earth and space science first, even though, at least that's been my experience with many of the teachers I've encountered, even though it makes up the smallest portion of the test, often because it's what feels the maybe the least scary or most comfortable for an instructor that's not super advanced in science. I've reasoned a little bit that maybe this has to do with the fact we start getting some Earth and space science. I don't know, very very young, and it starts feeling like that's more comfortable or something. But truly, life science, all the biology and things of that nature, ecology and whatnot, and the physical, like physics and chemistry, take up more. Um, Ah, excellent, Jesse. Yeah, that's the right way to go about it, I think. Instructors focus on it last. Often students tend to be the most comfortable with some of the earth and space science as well. Um, and so that's a good approach. Now, one second, I apologize, y'all. We're gonna be quiet. Don't normally webinar from home. I apologize for the brief interruption there. A little bit of physical science going on with some sound waves there. We could talk about if we wanted to, but let's stay focused on chemistry at first. Um, regardless, I see many of y'all jumped on life science. Again, another important thing, another thing that is 40% of the science test, but also something that maybe if our students have depending on when they left school, have probably already gotten a little bit of, depending on when they left school, they probably didn't get any physics or chemistry, or there's a good chance they did not get any physics or chemistry in high school. And so it's a good area to focus on if you can and you feel comfortable. And so that's kind of part of the message today is making this a little more comfortable and a little less mysterious and remind you that these are important sections of the GED too. Now, granted, this also feels like a pretty tiny specific skill balancing chemical equations. And I'll admit it's probably one of those things that, oh, we could probably pass the GED without being able to do it. And there's lots of those things that sometimes teachers start chipping away at. And eventually, yeah, you can lose a few points here and there by not doing this, that, or the other and still just pass. But we don't want to just start limiting the potential points for our students too early. And there's a lot to be gained from this skill beyond the specific skill related to critical thinking and paying attention to the details on the test and questions and things of that nature that reinforce other learning. Also, it pulls the mystery back for those students. Maybe this is the first time they've seen some chemistry and they go, oh, balancing chemical equations wasn't so bad. I want to pursue chemistry later when I move out of this adult ed program and on and pursue a career. You never know. So, but let's move on with it a little bit and see what we've got coming up next. So, another reason we're focusing on chemistry and balancing chemical equations is that it's a topic listed under the high impact indicators. High impact indicators are things identified by the GED that are often missed and, as it says here, often overlooked in current test prep, and also things that apply across multiple context areas. So, balancing a chemical equation is pretty similar to balancing an equation in algebra, a little less mathy of an approach, a little less math phobia involved, and so a good way to ease into this topic as well. Um, and so anything that's on that high impact indicators list is a great place to put in some extra effort and energy because it's something that is as it says here, well suited for classroom instruction and simple yet essential for students to master. So chemical equations is on there as simple yet essential, and we're going to see why it's maybe a little simpler than you thought, or how students can gain some understanding and some points, even if they can't balance the entire equation. So when I say they can gain some points or gain some knowledge, even if they can't finish the entire balancing process, that's a little bit of what I talk about here and what we're going to call prep for balancing. Okay, so we're going to look a little bit at the parts of a chemical equation and the way you get ready to balance to decide if an equation is balanced or not. And those things can help gain some points and some knowledge, even if a student doesn't work all the way through the entire balancing process on a test. So, chemical equations and the conservation of matter, right? So, what is a chemical equation, right? So you can start off right there with students with some simple understanding and definitions. That this is a symbolic representation of a chemical reaction, right? And so we can learn about reactants and products, the things created in a reaction, and the direction that a reaction takes. Some reactions are one-way reactions, some are reversible, right? Um, and all of those things are pieces we'll look at in this next slide here that can gain students points with just some simple knowledge. Now, what is the law of conservation of matter? Something important for the students to understand. Well, basically, it's why chemical equations balance or must be balanced. The idea that nothing can be created or destroyed, it can just change forms. And so another simple way of putting this to your students is everything that's there before the reaction has to be there in the end. There can't be more or less of any of the stuff, right? We can't create stuff out of nowhere. So we need to uh, take account for all the pieces. And we call that in this situation kind of conserving all the matter, all the pieces of what's there. Okay. And so, starting simply, kind of like we just mentioned on that last slide, just knowing the naming the parts of an equation or identifying which pieces of a chemical equation are reactants or products, or the reaction arrow, right? You can have, as we mentioned a moment ago, a one-way reaction or a reversible reaction. So if the arrow goes both ways, and often it's a little half arrow both ways, a little different than what I have here, but that means the reaction is reversible. You can get the product back out of then turned back into the reactants. But this arrow would just be it's a one-way reaction, right? Something that just learning that much might be able to help students gain a point or two on the GED that could get them to that passing level without a whole lot of in-depth instruction. But we can get a little deeper into all the parts here, right? So here's a nice representation, little infographic breaking down the pieces of a chemical equation for us. Okay, and we've got we can talk through what's going on here and have the students help us identify the pieces, especially with a chemical equation like this. We might it's a little overwhelming at first, but once they focus in here on the chemical formula at the end, the H2O, that's a pretty common chemical formula in advertising and everything, right? And so students will know that that's water. And so then you can start to have some discussions about, well, what's in water, or what makes up water, or what state of matter is water, and that can help them identify why this L is here. Oh, there's H2O. You can talk about the 2 being a subscript, as they mentioned over here, that tells you how many of those hydrogen atoms there are, whereas the 2 would tell you, if we were looking at the products here, how many molecules of water there are, right? There's 2 hydrogen atoms and oxygen atom joined together, and then there's 2 of those groups, right? And we'll have I've got another little picture to share with you in a minute that you can use, or you can draw out examples of that as you go. But as you noticed, I just started doing a little bit of of talking out what's meant between a subscript and a coefficient by saying there are two H's in this H2O, but then there are two groups of the H2Os together. Okay, and so then a little bit of math comes in as we start to count up how many hydrogens are really in that two H2O situation. But let's step back a little bit more. On a bigger level, or kind of larger view, we've got our reaction arrow, and it shows that this is a one-way reaction. And we've got the reactants, which will always be on the left side over here. You've got something plus something else, and so you can think of it as reacting to. It's not really adding together because we're not going to we don't always just put them together, right? We have to rearrange things, but the plus means the reaction between these. So this reacts with that. The reaction occurs where the arrow is, and the products are the things on the right side of the reaction arrow, the things that are formed. And then again, I mentioned briefly, we have some states of matter, which is not always represented in every chemical equation you'll see. But it's good to show students that they might see that, even if it's a bit more rare in kind of the level of chemistry we're dealing with. But a nice infographic. You've got all the pieces laid out for you for the students there, and you can talk about identifying all the parts of equation, even if they can't balance the full equation yet. We're gaining knowledge and points on the GED just by understanding a little bit more of what we're looking at, making it a little less mysterious. Okay, so how do we move beyond that? Well, we started a little bit with this already because we're gonna get ready to balance again, and answer some questions along the way. We're going to count what we've got and organize it. And that's where I say we kind of started just a little bit there as I started to count some of the hydrogen atoms. But we're going to count and organize things, and then we're going to interpret or understand a little bit more what we're counting and what's going on with the equation. Even if we don't understand all the chemistry of what's there, we can count and understand the larger groups of what's happening a little bit. Then we can gain some points on questions related to limiting reactants, which there may be. It's pretty common. So these are some common topics related to balancing equations before the actual balancing. Is it balanced or not? And limiting reactant questions. So let's look a little bit deeper at that. So to find out if it's balanced, we're going to just do a little simple process. We're going to write out the equation. We're going to count all the pieces of the equation, and we're going to compare those. And so we're going to count those in a nice, and put the pieces in a nice table of reactants and products for each element in the equation. Okay. And to do that, we have to help our students understand the relationship between coefficients and subscripts and counting. And so I mentioned just a moment ago that I had a little chart I wanted to share that will help explain that a little bit more to some students, or you might draw it out yourself, or make diagrams or models to display this and make it sink in a little deeper. But if we've got a hydrogen atom, and then actually, well, here we've got hydrogen with a 2, an H2. So there's two hydrogen atoms kind of grouped together, floating around. But then there's 5 of those groups. So there's actually 10 hydrogen atoms in this 5H2 scenario, right? Because it's similar to something like this down here, like 3CO2. And we can build up to that. If we've got C means 1 atom of carbon, we'll make that a black dot. We could have O is 1 atom of oxygen, and we'll do it as a red dot in this diagram. Well, O2 would be 2 reds connected together, hanging out, right? CO would be a black and a red hanging out. Well, what about a CO2? Well, generally, you don't even have to talk about the formation and things yet, but this is a common, for a variety of reasons. You can just say this is a common way that they express themselves. The O would be, or the C carbon would be in the middle with the oxygens hovering around, instead of like C, like black, red, red, or something like CO2, right? That you would turn it around to be in this common form, even if you didn't want to get into the depth of why, right? And then what if you had three of those CO2s? Well, here it is, three CO2s. And you can easily count how we went from O2s to CO2s to three CO2s. Now we've got six oxygens and three carbons because of the O2 factor. And so you can see a little multiplication or a little visual interpretation helps students understand what's happening there. Okay. So let's try that a little bit together. Here we've got the equation for photosynthesis. And again, if students have had a little bit of biology or chemistry, this might be one of the things they've heard of, and they may be able to identify some of the pieces of it because H2O is there in the equation, even if water isn't written under it in whatever form you show students or CO2. Sometimes students know that's carbon dioxide if they've had a little bit of an introduction. They're not going to know C6H12O6, right? But that doesn't matter all the time, which is part of in a moment. We'll talk about how this can reinforce pattern recognition and critical thinking, even if students don't understand all the chemistry beneath what's going on. But let's start with a counting demonstration, and y'all help me count here. So if we're counting in our photosynthesis equation, let's start with the reactants, okay? So the reactants are going to be on the left side. They're the things that react together before the reaction arrow. So these two things come before the reaction arrow. When the arrow happens, they react and they produce the products, the things after the reaction arrow. Okay, and again, we'll just reinforce that to our students and over. So let's count the reactants first. So y'all help me out. How many carbons are there in the reactants? Excellent. All right. Thank you, Kay. Six. And you're right. We have six carbons. How about oxygens in the reactants? Well, let's do it together. Let's eight. Excellent. All right. Oh, good little trick here. So look in this first one in the carbon dioxide, we have an O2 and there's six carbon dioxide. So that's our 12. But then over here, we have H2O, but there's six H2O. So that's six more oxygens. So yeah, we're up to 18. All right. Now, how about hydrogens? How many hydrogens do we have in the reactant side? Excellent. I see the 12s coming through. Yes, we've got the H2O, and so that's two H's, and then there's six H2Os, so that's two H's times six of them, so that's 12 hydrogens. Excellent. All right, well, I think you see where I'm going, hopefully. How about on the product side? How about the carbons? How many carbons do we have over there? Yes, I see people coming in with six. Exactly. And here they are in our glucose. These are the only carbons. There's just C with a subscript of six. Excellent. How about on the oxygens? Excellent. Yes, they're 18. And you can start to see you maybe y'all have already guessed that I'm giving you a balanced one so we can prove it's balanced. But let's count them up again and make sure. Here's six of them in the glucose, O6. And then here's O2s for the oxygen, but there's six groups of that. So there's our other 12. So 18, correct. And then finally, just to confirm, how many hydrogens do we have in the product side? Excellent. Yes, thank y'all. The 12, and there it is right there in our glucose. And so we can confirm that this is a balanced equation. Now, if any of these things hadn't matched, it would be not balanced, right? And so if the question is the equation balanced or not, you create a little table and count out your atoms. And if there's ever ones that doesn't match, like if we had an 18 oxygen and then 12 oxygen in the product, say, well, we would have lost some oxygen. And we'd have said, oh, something's wrong. This equation is not balanced. And then we would go to the next level of instruction and discussion to say, well, what do we do about that? Right? But excellent. Y'all are doing great. So this is a balanced equation. Okay. Now, just a little bit based on what we've talked about so far, we can answer a few sample kind of GED questions. So again, we haven't even balanced anything yet, but we can decide here if we've got swimming pools are disinfected by adding chlorine to the water. This reaction produces acids that kill bacteria, viruses, and algae in the pool. And then here they have an equation. And by reading it, hopefully our students can gather some information that Cl2 must be chlorine and H because they know H2O is water, and it said adding chlorine to the water. So when these react, the reaction produces this other stuff, which is some kind of acids. Okay. And they don't have to know that to know what those are to answer this. Which are the product or products in this chemical equation? So what are the products? A, B, C, or D? Excellent. I see some coming in. Yes. And notice again, we just had to know, oh, it's the things to the right of the arrow. In fact, I should have asked the question before I got any deeper analysis. Just knowing that our arrow goes to the right and it's not reversible, these are our products, right? Excellent. But then you could go a little deeper, like we mentioned, and have them start to analyze a little bit of what's going on here in terms of this must be chlorine, Cl2, because this must be water, H2O, and that sort of little critical thinking depth. All right. How about this one? Clouds are able to produce water when hydrogen gas and oxygen combine. So, which are the reactants of the equation? Exactly. Hey, again, just a simple identifier here of what the pieces of the equation are. All right. Glucose is a sugar used by living organisms for energy. When glucose reacts with oxygen, and then we have 6 CO2, they're kind of helping us out here a little bit, it creates carbon dioxide and water and ATP. Oh, this feels a little weird. But which is the correct process for this? Which of the answers describes what's written over here? Excellent. Yes, C. And notice a couple of things that are interesting here. Glucose doesn't have the chemical equation for it, even though the others do. Okay, so you have to use a little bit of critical thinking. And this also feels a whole lot like the photosynthesis we just looked at. But you don't want students to get too caught up in, oh, I know what this is. The sugar has to be the product or something because that's from photosynthesis. This is actually related to cellular respiration. And so y'all are correct though. C describes it. A glucose, the thing that we don't know the exact formula for from the paragraph, plus the 6 oxygens they gave us, reacts and turns into the 6 CO2s and the 6 waters. Excellent. Good job. So a little pattern recognition. Again, even if they don't know all the depth of what's going on, they can gain some knowledge and some points here. All right. Now, a little something else that you can add in at this point, talk about the concept of limiting reactants. Okay, and this messes a little bit with the idea of a balanced equation, but that's a good time to introduce it. Okay, so a limiting reactant is the substance that runs out first and stops a chemical reaction from continuing. So if carbon plus two oxygens reacts and turns into carbon dioxide, if you add 3 carbon atoms and 5 O2 molecules, what is the limiting reactant? Yes, exactly. A. That's what would stop the reaction. You'd run out of the carbon, and so you would be left, there'd be some oxygen just kind of floating off that didn't turn into CO2, right? All right, excellent. Now let's take a little time to talk about the balancing itself. Okay, there's 2 ways to balance a chemical equation, and we're going to look at the the less mathy of the two, I guess you'd say, even though that's not a very professional sounding term. One is focused on a process, and one is focused on a more of an algebraic process as well, but more of algebraic interpretation of the problem, and one more of a rebalancing, counting and rebalancing as you go based on what we've already talked about. So we'll look for first to that concept, and this is what I would do with my students. Um, we've got a little equation here and some numbers already charting out, and they've highlighted a split here at the reaction line. So these over to the left would be the reactants, and these to the right would be the products. And notice when they first counted, some things weren't balanced, it looks like. Okay. And so the first thing you need to do is decide, is it balanced? And that's really the count and compare. And so if we're able to, I wasn't able to fit multiple images on this one together, but imagine that the red lines aren't there. You can see that carbon 3 on the reactants, but then counting only 1 in the products is clearly unbalanced. Where did those 2 carbons go? They can't just disappear. Or the same with the oxygen. O2 over here in the reactants, but then an oxygen and O2 there. That's 3 oxygens in the products. Well, where did one just appear from? And those carbons couldn't have just changed into an oxygen or something. So something's going on here. And then if we look a little, they haven't even noticed yet in their process with their red marker that the hydrogens aren't balanced either, right? There's 8 hydrogens. And then if we go over here in the products, we've got an H2O. So there's only 2 hydrogens. So we've got to get a little deeper. So we've counted and compared and decided this one we're looking at here is definitely not balanced. And then they've already taken a first few steps to try and balance it. Okay. And if you notice, that first step relates to the step here. If it's not balanced, then we're going to balance it. And what are we going to do? We're going to leave the hydrogens and the oxygens to the end when possible. And we'll start with, after that, what's the simplest thing to balance first? And so they're trying to ignore the hydrogens and oxygens. And that brings them to deciding that the CO2 is the easiest thing to work with first because there's a hydrogen and an oxygen and everything. Um, right? Okay. And so as you go, you're going to then recount as you make changes, as you change the coefficients. And at this point, you'll have to remind your students part of the balancing is that we cannot change the subscripts. We can only change the coefficients. And really, I should have mentioned that even earlier when we were talking about the pieces of the equations and identifying all the parts. Remind students, you will change coefficients to make balancing happen later, but you'll never change the subscript. And now that we're here in the later time, remind them we're going to change coefficients, not subscripts. And so they start going through and counting and changing a coefficient. Well, they put in a 3 here. Well, that changed the carbons from 1 carbon to 3 carbons. Okay, so they make that change here. And that changed the oxygens too, because now you had an O2. Well, that's 6. If there's 3 CO2s, that's 6 O2s or 6 O's plus the one over here. Now we've gone from 3 to 7, right? And so you start changing your chart and recounting as you go. And then slowly you'll come to find you have the same number of reactants and products and you're balanced. Okay, so let's give that a little bit of a go together and show that it's not so mysterious. Okay, so who can tell me what the first thing we should do is, or remind me when looking at this chemical equation here, what should be our first step? Uh-oh, nobody knows. I'm not doing a good job. Well, is it balanced or not? Let's start there. So how many nitrogens are there in the, right, count. Perfect. Thank you, Christina. Exactly. So how many nitrogens are there? Excellent. K is already ahead of it. No, it's not balanced because we have 2 nitrogens in our reactants. And if we look at our products, there's only 1. We have 2 hydrogens. And if we look to our products, we have 3. So these are not going to match. So it's not balanced. So then what's the first thing we should do to try and balance it? Well, they say ignore hydrogens, and so start with the nitrogens, right? But here, this is a little bit of a funky twist because we've already got 2 of them here. We don't need to grow this nitrogen by adding a new coefficient. We need to grow the nitrogen in the products. There's only 1 of them there. We need 2 of them, right? So we need to, we have to understand a little bit about what's going on and say, okay, well, let's add some coefficient to our products that'll raise up the number of nitrogens to match the number of nitrogens in our reactants. So what should we do? 2n, exactly. I see it already coming through. So we'll add the coefficient 2. Now we need to do a little recount. We've got two nitrogens, two hydrogens still, and then we had three, but now there's two of those groups. So really we have six hydrogens. So what do we need to do to, it's still not balanced. We need to balance the hydrogens. What could we do to balance the hydrogens? Oh, sorry. What did I say? I misspoke. The two on the NH3, yes. And then three on the H2, exactly. Yes. Thank you. There you go. And so now we're looking at um, matching our hydrogens. We have two H3s over here in our products as part of the NH3, which gives us six hydrogens. And then now in our reactants, we have three H2s, which gives us six hydrogens. Excellent. And so if we counted it all again, it's all perfectly balanced now. Okay. How about this one? Okay. First thing, let's count and decide, is it balanced or not? Okay. Well, I'm seeing uh, one more and three more in my groupings if I'm looking at everything. So it is not balanced. Excellent. So what would be the first thing to do to balance it, do you think? 2p. Excellent. Yes. So let's do that. Bring in 2p plus 1O2 uh, reacts and turned into, we've got P2O5. So we've got the p's are balanced, but our fives are not. What do you think we can do to get the fives closer to balanced? How do we match a O2 with an O5? Start thinking that students are starting to say, I thought this was science class. Why are we doing math? Well, we're looking at very much like finding a common denominator or something here. So 2 and 5 could turn into 10 if we added a 5 to our O2 and a 2 to our P2O5, right? Um, but now, what did we just do? Yes, now we, oh, perfect. There you go. I see someone already stepping ahead. Now we messed up our product, our reactant side. And so we need to change our 2p to a 4, right? And so it was a little bit of a back and forth of a process, but again, nothing more than counting, resetting, counting again, and trying to do some, basic math, right? With your kind of multiples and things. Okay. Excellent. Let's try one more here. Okay. So a little more complicated, but one we've seen actually, and one we'll see multiple times throughout the test and such. If you notice, this is back to the photosynthesis equation. So let's just start very simply with counting the carbons. We've got one carbon in our reactants. How many carbons in our products? Six. So it's not balanced. So we don't need to take the time to count out all the other pieces yet, right? Or in terms of to decide if it's balanced. We're probably going to want to count them out for the balancing, right? But we could, if the question for our students was, is this balanced or not? We can remind them, you don't have to count everything. If you see one piece that's not balanced, stop, answer the question. It's not balanced, move on. If you have to balance it, you're going to need to keep counting all the pieces to keep track of what all you need to do. But that's not always the answer they're looking for, right? They're often looking for a piece along the way. Is it balanced or not? Or how many reactants are there? Or, that type of thing. But we know it's not balanced here. So we started with ignoring hydrogens and oxygens, which they guide us to. And that leaves us with looking at either the CO2, well, really the CO2. O2 might be the simplest. They said ignore the hydrogens and oxygens and then choose the simplest. Well, these O2s match, so but that doesn't. Well, let's look at our CO2. Let's go with the carbons. Let's match our carbons. What coefficient would I need to put here to match the carbons from the reactants to the products? Excellent. Yes, a six. So let's put that in there. And then as we move along, that gives us six carbons. And now we have our six carbons. And we can count out all other stuff a little bit. That gives us 12 oxygens, 13 oxygens. Over here, we've got six oxygens, eight oxygens. Oh, this is getting a little tricky. What do you think we should do next then? Yes, I agree with Kay. That's what I was gunning towards. Let's go for the hydrogens, which means looking at our H2O. So if we've got an H2, what do we do with that to match the H2 into our products? A 6H. I see it there, Stephen. Excellent. Thank you. So many people answering so quickly. I can't acknowledge all of y'all. Thanks for the participation. But there we go. We've got that. Okay. Now let's count again. So we had six carbons. All right. That's still good. Six carbons. Our O2 times the six is 12 oxygens. Now here's an O, but there's six of them. So we're up to 18 oxygens. Over here, we've got six oxygens, two, we got eight oxygens. Okay, we're gonna have to do something with that. But our hydrogens, six of the H2s is 12, and over here we've got 12. Those are balanced. So we don't need to do anything with this scary looking glucose because so far the carbons and hydrogens are matching up. So like let's not mess with a good thing yet, right? That's like, or we got some stuff balanced. But let's focus on our oxygens a little bit. So we mentioned we had 18 oxygens over here. How are we going to turn an O6 and an O2 into 18? Maybe y'all are already answering. Yes, perfect. There you go. To make it clear, Maurice. Thank you. And Sandra, perfect. Yeah, we're going to turn that to a six O2s. And now we're balanced. Okay. And you may have already recognized this as kind of the basic balanced equation of the photosynthesis that we looked at earlier. But you can acknowledge to your students or remind them it could also have turned into something like this. This is also balanced. Now, ignore, I'm sorry, this all of a sudden looks like fractions. Pretend this is a next round of coefficients. So it could, instead of 6, 6, 1, and 6, 12, 12, 6, and 12 is also balanced. There's just more stuff reacting, right? And there are a few, there's a potential question on the GED related to that kind of a concept. Like it starts out with, whoops, what if you had this equation and then it asks questions about what also is balanced, or I don't know, I'm losing the exact wording, but like if I had a one here, if I had 6, 6, 1, and 6, that wouldn't be balanced anymore because there are two here rather. We have a one implicitly. Sorry. A two here, it suddenly wouldn't be balanced. But if I doubled everything else, it would be balanced again. Or but if I doubled my carbon dioxide, didn't double my water, doubled my glucose, and doubled my oxygen, the water would be what was messing it up, was what was not balanced, right? You see what I mean? So it could turn into like 12 CO2s, 12 H2Os, reacts and kicks out six, or any other, multiple of. Could I reduce it down? Could I turn it into 3, 3, 0.5, and 3? No, exactly, because there's no such thing as a half a molecule of glucose, right? This is kind of like those real world math questions where you can't buy a half a bag of mulch, right? You got to buy the full thing. And so we couldn't reduce it down like that. Okay, excellent. I'm glad y'all are into it and gung ho. You know more than I expected, maybe. Uh, but thanks for great answers, participating. Now, here's another method. We're not going to dive deep into this method, but I want to acknowledge it. Some of the more math inclined teachers might kind of recognize what's going on right away and see how you could maybe teach this approach in a math class as a way to show the bridging between science and math. Because it's a little bit higher level, but basically you write down the equation, assign a letter to each substance, so each unique um, molecule essentially, and then check the number of each element found on both sides and set those equal to each other. And then you have to solve this system of equations, right? So a bit more advanced than even some of the algebra students. Well, I mean, we do have to solve a system of equations, Um, but anyhow, a little more complicated, not necessary though, and not the kind of approach where you can build um, knowledge for different questions along the way. That's one thing I really like about this first balancing approach is we were able to identify um, we were able to identify coefficients, subscripts, individual atoms, a molecule, girl, product, reactants, a reaction sign, the products, all the different pieces that would potentially be tied into other questions, as opposed to just knowing this slightly more complicated way um, to do it. But I'm not saying don't teach it. If you like it and it's cool, it would be fun to do with a certain group of students for sure. Now, some other things that may be fun to add into the understanding of what's going on with the chemistry here and to keep science class fun, there's a variety of things you can do. So we do have a handbook connected with or conjoined with this webinar, and there's a complete lesson plan in there. There's some prepared worksheets. There's an answer key for instructors related to those worksheets. Girl, stop, come here. Um, and that sort of thing. And I'll show you where that is in just a moment. But there's also some other things you can do. For example, a really fun activity is making gummy bear atom models. Or and here's some examples of what I've done with students. Now these are all individual um, molecules. Like here in the middle with this is a CO2. So the red is the carbon and the oxygen is the yellow. So we've got a CO2 versus yeah, so here's a H2O because our O is yellow and our H is green. So we've got a CO2, but then an H2O. And we were talking a little bit about some of these different patterns in which things can connect. And then if you want to go the full way, this isn't a picture of that, but you can go along and have like the full photosynthesis equation. You can count out the number of greens in the reactants and the number of greens in the products, and you can know that your hydrogen's matched and count out your yellows and count out your yeah, I think methane is on here too. I see someone, yeah. Um, exactly. And you can make up whatever color chart you want, right? You could also and this is a great fun. This is actually truly a student doing it in one of my classrooms and the examples. And I wish now I could find the pictures of the full equation laid out instead of just some of the pieces. But it's a great day, and people get to eat the gummies as they're working or when they're done as well. Whiteboard battles. If you've got a real advanced class that likes a little competitiveness, you can have competitors try and balance equations against like competitive teams try and balance equations. You can have human equations similar to the gummy bears, but watch people move throughout the room. If everybody has like an H or an O and you can move them until to set up a physical equation and count out the pieces and kind of see where people fall. Like how many O's? Raise your hands, and you can quickly count. Are we balanced or not? And move people around and that sort of thing. Another fun approach there to that. Okay. So yeah. So a quick summary here. Really, one thing I love about this as an example is that the chemical equations there's kind of different levels of understanding where students can gain more points on the GED as they get a greater level of understanding, but they don't have to be able to do all of it to learn something and gain a few points. Like the initial are things balanced is pretty simple to figure out and count out, or maybe even just identifying the pieces first. I should add another little circle maybe and then balanced, is it balanced or not? And then a little more understanding of the relationship between the reactants and the products, and then actually balancing the thing are all different levels of understanding. And that can all help students gain some points. Some won't understand the full balancing process on the first go around, which is fine. But even on that first go around, if they don't make it back to another day of balancing chemical equations, they'll have gained some knowledge about the pieces of the equations that'll still help them on that GED in the end. Um, so Yeah, I think I have an extra moment here, which I was hoping for. I want to go and show you before we close and take questions where you'll find those other resources and the handbook, particularly related to today's webinar. So if you go to your ipday.org, floridaipday.org, and sign into your account. There's a couple of different places you can find the materials. Along the top toolbar here under resources, you can always go into the section related to the subject area you're looking at from there. Or that same material is housed down here at the bottom of the page. Well, it's not the bottom of the page, but the bottom of that first opening section here below the picture as you work under each header here. So ABE resources, webinars, lessons, videos, links, GED, webinars, handbooks, lessons, videos, links. Now, the handbook I'm talking about won't be under here. Those are a different type of thing. It would be related directly to the webinar. So say we're looking for today's webinar. One place we could find it is under GED and adult high school resources. We'd click webinars. It'll open up and here's some recent webinars. Here's our webinar for today, and you'd be able to play it pretty soon. It's not there right now, but here's the PDF of the presentation and the PDF of the handout. Okay. And this is also, if you were looking under ABE and under webinars, because the subject matter relates to both, it's kind of double how it's not housed in two places, but it's listed in multiple places to make it easier for you to find. This today's topic would even be listed under ESAW because we have some ESAW students working on their GED even before officially in their, well, might be working on it at the same time, right? And but it wouldn't be under the IET because there's no specific tie-in to the IET piece with what we're doing today, right? So again, from the home page under resources at the top or under any of the sections at the bottom, you'll find our webinars along with other resources as well. Okay. Um, yeah. Well, is there any other uh, questions, thoughts, feedback for me at the moment? Um, and if not, before you go, we do have a survey we'd like you to complete, but I'd love to take a few more questions here. All right. Well, the survey's up on the screen now, and we'd love for you to let us know what you thought of today's material, and if you have any other thoughts or questions following today and you want to reach out again, please, H. Gertner at, let me put it back up there, at IPDay, floridaipday.org. And yeah, thanks again for being here. So before we go, also, thank you for your feedback. Thanks for being here. We've got always something new coming up. Next week is a Tech Tuesday, not a webinar Wednesday. We're back to a Tech Tuesday on the 18th, titled Smarter Teaching with AI, Save Time and Spark Learning. So we'd love for y'all to join us, and I'm sure it'll prove to be an excellent session. Sounds like a great topic.